Hi dear students, today I am going to take a chapter real numbers. In real numbers we will see natural numbers, whole numbers and integers. Natural numbers are called natural numbers which contains from 1 to number. You can choose any number 1, 2, 3, 4, whatever it may be. Whole number means it can include 0 also. And integers means it may be negative or positive with 0. It is known as integers -3, -2, -1, 0, 1, 2, 3, etc. As in the case, we will come to see the natural numbers. In natural numbers, integers, we have seen rational numbers if anything that is under a by b or p by q. If p is any integer and q is non-zero integer, then is a rational number. It is known as p by q. P divided by Q form or A by B form. Anything under A by B form or P by Q form, it is known as rational number. In rational number, it may be expressed as 5 by 9, -3 by 1, 4 by 3, 1 by 5, etc. It is in the form of ratio of integers. We will call as ratio of integers. In the numerator, integer should be there. In the denominator, non-zero integer should be there. For an example, non-zero means it should not contain any zero. Integer means any number, -3, -2, -1, anything, -8 we can write. And non-zero integer, it may be 1 or 2 or anything. Next, coming to the topic rational number. Rational number means already we know that it is in the form of P by Q form. It is in the form of P by Q. We can see here P by Q form. It is known as rational number. If we take any rational number, for an example 9 by 4 we have taken. In 9 by 4, if we divide that one 9 like this with the 4 number, 4 2s are 8, so 1 is remaining and we can put decimal point and we can take 10. 4 almost 10, 4 2s are again it is 8, 2 is remaining, we can take 0 here. We have taken the point, and 4 5s are 20, we will get 0. So 2.25 is the answer for here. Then another example is 11 by 3. If you go on dividing 11 with the 3 means, we will not get the end point, or remainder will be 0, like that we will not get. So we are taken as 3.6 something ... So we will call this one as 3.6 bar. Next, coming to the topic irrational number. Irrational number means we have know that rational number will be in the form of P by Q. Irrational number will be number whose decimal form is non-terminating and non-recurring are called irrational number. These decimals numbers are non-terminating and non-recurring. For an example, we are having no particular value of that decimal point or anything. See here, we will see that. See this one, it is not ending, it is not having a particular value or perfect value. See, this is also 3.14, this is the pi value, and this is also 2.61 and 1.90 something, whatever it may be, 2.60012 we can't get the value. So these are all called irrational number. Irrational number whose decimal form is non-terminating and non-recurring are called irrational numbers. Best example they have given root 2, root 3, root 5, root 6. Root 2 contains 1.414213 something else, and root 3 1.7 and 2.23 something else, 2.449489. These are all the values. It is having infinite values. So these are all called irrational numbers. There is no perfect number at the ending, and we will not get the 0 as the remainder in the division form. So it is known as rational number. Now I am going to take a topic name real numbers. In real numbers, we will come to see about rational number and irrational number. In rational number, we see that integer by non-zero integer, terminating or non-terminating, recurring. And in irrational number, we will see non-terminating, non-recurring. Some basics we need, so we will tell that integers means it is in the form of -2, -1, 0, 1, 2, 3, anything numbers. And whole numbers means it should contain from 0 to in number. And natural number means 1, 2, 3, 4. We can go next topic, the fundamental theorem of arithmetic. In fundamental theorem of arithmetic, we will come to find the HCF and LCM. What do you mean by HCF? HCF is product of the least powers of common prime factors of the number, and LCM means product of the highest power of all the prime factor of the numbers. HCF and LCM we have studied in earlier classes, so we can go directly to the problem. Here one problem is that find the HCF and LCM of 180 and 54. Now we can take the HCF and LCM for 180. We have to split first that one from 2, that is the lowest number we have to take. 290 is a 180 and 245 is a 90. Then 5 9 is a 45, 3 3 is a, this is 3 3 3 is a 9. At the end we have to get 1. If you don't know this trick, we have to get 1 last. So we are having 2 times, 5 1 time, 3 2 times. So that is written here. And 2 into 2, 3 into 3 into 5. So we will get 2 power 2, 3 power 2, 5 power 1. Next we can take the 54. First we have to divide it through the 2. 2 2s are 4 and 1 is remaining, 2 7s are 14. So again we have to take, it will not divide through 2, so we have to go for next number, it is 3. 3 9s are 27, and then come to the 3 3s are 9. So again we have to divide, we should get the last one. So we are having 2 into 3 into 3 into 3. So we can write it as 2 power 1 and 3 power 2. Take 54 as 2 into 3 power 3. So next HCF is 2 power 1 and 3 power 2, because in 180 we are having 3 square. 2 power 2 is there, here 2 is there, we have to take 2 only HCF, and 3 power 2 is there, and here also 3 power 2 is there in common power. So HCF is 2 power 1 into 3 power 2. So we will get 2 into 9, it is 18. The HCF is 18. Then come to the LCM. LCM is all the powers which is having highest power we have to take. 2 power 2 into 3 power 3 into 5. All the numbers, 5 is having 1 power, so we have to take that also. So if you multiply means 2 2s are 4 and 3 3s are 9, 9 3s are 27, then 5 power 1 means 5. So we will get the LCM as 540. At the coming to the final conclusion, we have to know that HCF into LCM. HCF is already we know that it is 18 and LCM is we know that 540. So we have to multiply those things. So you will get 9720. This is the answer we get here through the HCF into LCM. If you multiply means we will get that answer. we have to do this problem as step by step, then we have to write this step also. Then product of the number, so 54, then this number we have to take 54 and 180, it is also 929720. Then we can conclusion, HCF of A into B into LCM of A into B is equals to A into, here we consider A into B as 180 and 54. So HCF of A into A comma B is 18. HCF of A comma B is 18 into LCM of A comma B is 540. So we will get is equals to 180. AI means 180 into 54. Now we can go for the exercise 1.1. Express each number as product of its prime factor. First one we are having 140 as a problem. 140 as a problem means, see, we have to divide 140 through the lowest number, it is 2. 270 is the 140. Again 70 will divide from the 2. 235 is the 70. Again 35 can divide it by through 5. 5 sevens are 35. 7 can be divided by itself only. So 7 ones are 7. So product of its prime factor is 140 is equals to 2 power 2. Then 5 power 1 and 7 power 1. So this is the writing way of the product of its prime factor. Second is 156. So 156 we have to write as it is in the forum. 156 can divided by 2. That is the 2 is the least number which can divide any number. So 278 is the 156. So we have to take 2. First one is finished. Second one is 2. 39 is the 78. So again 39 can divide by 3. 3 13s are 39. So at the end 13 we got. 13 cannot be divided by any number. So 13 itself it is the divisible number. So 13 ones are 13. Then we get as product of its prime factors is 156 is equals to 2 power 2 into 3 into 13. Next problem is 3825. 3825 can be splitted as like this. So 3825 can be divisible by the least number, that is 3. 3 into 1275 we get 3825. So it can be divided by 3. Again 1275 can be divided by 3. 425 is 1275 you will get. So 425 is 1275. Again 425 can be divisible by 5. 585 is 425. Again 85 can divided by 5. 5 17 is 85. 17 can be divisible by its number, one number, that is 17 ones are 17. So at the end the prime factors are 3825 is equals to 3 power 2, 5 power 2, 17, because 3 is repeated 2 times, 5 is repeated 2 times and 17 is repeated in 1 time. So this is the way of finding the product of its prime factors. Next problem is 5005. So 5005 can be divisible by 5. So 5 into 1000 not 1. So you will get 5005. Again 1000 not 1 is divisible by 7. 7 into 143 we will get 1000 not 1. Then 11 13 is 143. then 13 ones are 13. So the product of its prime factors are, for the 5000 and not 5, 5 into 7 into 11 into 13. Here all are having single power, it is not repeated, so we can tell as 5 power 1, 7 power 1, 11 power 1, 13 power 1. Then another problem is 7429. 7429, it can be divisible by the least number is 17. So 17 into 437, you will get 7429. Again 437 can be divisible by 19. 19 into 23, you will get 437. So 23 ones are 23. So all are having single power. So it can be represented by 7429 can be expressed in the prime factor method as 17 into 19 into 23. Important question asked in CBSE examination, and in the CBSE schools they will ask some like these questions. Express each number as a product of its prime factors. One of the problem we have taken 1000. 1000 we have to take like this. Then which is the lowest number, we have to divide through that one. 2 500s 1000. Then again 2, again 250 you will get the again 2 125 you will get 125, which will divide by only 5. 525 is a 125. Again 25 divisible by 5. 5 5 is a 25. Then again it 5 divisible by 1. So you will get 2 into 2 into 2. So this you can write it as 2 into 2 into 2 like this. Then 5 is repeated 3 times. So we can write it as like this, 5 into 5 into 5. At the end you can write it as 2 power 3 into 5 power 3. This is the prime factor method. Another problem we are having 72. So 72 further can be divided as from 2. 2 36 are 72. Again 2 18s are 36. Another important question is 72, which should be expressed in the form of prime factor method. So according to the prime factor method, we will see that 72 can be further divided as 72 can be divided by 2. 2 36 are 72, then 2 18s are 36, then 2 9s are 18. 9 can be divided by 3. 3 3s are 9, then 3 1s are 3. So 2 is repeated 3 times, 3 is repeated 2 times. So further we can write it as 72 is equals to 2 power 3 into 3 power 1. Thank you. Dear students, now we can go to next topic of exercise. Find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equals to product of the two numbers. The first question is 5, 10 and 12. So 5, 10 can be divisible by two numbers, that is 2 and itself. So we can, the smallest number is 2, we have to take that one. 2 255 is 510. So 255. Again 255 can be divisible by the lowest number is 3. So 385 is 255. Again 85 can be divisible by 5. 5 17 is 85. So 17 can be divisible by itself, says 17 ones are 17. So it can be written as it is. 2 is 1 times repeated, 2 is power 1, 3 power 1, 5 power 1, 17 power 1. Next 12. 2 6 are 12 and 6 is divisible by 2. 2 3 is a 6 and 3 1s are 3. So it can be written as like this. Then 12 we can split up into 2 power 2 into 3. Then HCF of 5 10 and 12 is 2 and 3 only, because 5 10 having 2, here also 2 is there, the both are having the common power is 1, so we have to take 2 power 1 here, and 3 also is common in both the numbers, so we have to take 3. So 2 3s are 6, that is the HCF of 5 10 and 12 is 6. And come to the LCM of 5 10 and 12, it is highest power should contain in both the numbers, it should be repeated and common also. And 2 power 2 is the highest number, it is in the 12, and 3 is in both the numbers, and 5 and 17, so we have to write here. So we will get the product is 1020. So by the verification method, we have to find that HCF into LCM. LCM already we know that 1020 and HCF is 6. So we have to multiply, means we will get the 6120. Then product of the two numbers. So product of the two numbers means it is 5 10 and 12. These are called the product of two numbers 5 10 and 12. So you will get the answer 6120. Then it is also both are same, so HCF of A comma B into LCM of A comma B is equals to A into B. This formula satisfies here. Thank you. Hi dear students. Again one of the problem we can take, find the LCM and HCF of the following pair of integer and verify that LCM into HCF is equals to product of two numbers. So the first question they have given is 336 and 54. We have to do the split up for these things. 336 can be divisible by 2. 168 is 336. Again 284 is 168, and 242 is 84, and 221 is 42. Then 21 can be divisible by 3 only, not 2. So we have to take 3. 3 7s are 21, then 7 1s are 7. It is 336 can be split up into like this: 2 power 4, 3 power 1, 7 power 1. Then come to the 54 split up. So 2 27s are 54. 27 can be divisible by 3. So 2 9s are 27, and 9 can be divisible by 3. 3 3s are 9. 3 can be divisible by itself. 3 1s are 3. So here also we got 54 is equals to 2 power 1 into 3 power 3. So HCF is equals to 2 into 3, because here both are having the 2, and it is the highest power is 2 power 1, and 3 also common is that 3 power 1 is common in both the numbers. So 2 3 is 6. HCF is 6, and LCM is we are having common and with highest power 2 power 4 and 3 power 3, and which is in the one of the number also we have to take that one 7. 2 power 4 into 3 power 3 into 7, that is equals to 3024. Now we have to go for verification method. In verification method, LCM into HCF, that is equals to 6 into 302524. So we will get 1 lakh 18,144, and product of the two numbers is 336 into 54, 18,144 we will get. So it verifies that LCM of A comma B into HCF of A comma B is equals to product of two numbers, that is A comma B. Thank you students. Hi dear students. Today we can go for the problem solving on find the LCM and HCF of the following integer by applying the prime factorization method. One of the numbers in the problem they have mentioned that 17, 23 and 29. It is a repeated question, children, in CBSE exams and board. 17 can be split up into 17 into 1, 23 can be split up into 23 into 1, 29 can be split up into 29 into 1, because it cannot be divisible by 2, 3 or any number. It can be divisible by with its own number. So HCF of 17, 23, 29 is 1, because in all these three numbers it common is 1, so HCF is 1. Coming to the LCM, that is equals to the 17, 23, 29, into 1 also we have to write as it is. So we will get 11,339. This is the HCF and finding the HCF and LCM by the prime factorization method. Thank you. Hi dear students. Now we can go for the next problem. Find the LCM and HCF of the following integer by applying prime factorization method. So 8 can be divisible like this. 8 divided by 2. 2 4s are 8 and again 2 2s are 4, again 2 power 2 ones are 2. So we can write it as 2 power 3 into 1. Then 9. So 3 only it will divide. 3 3 is 9. Then 3 power 1. So it is written as 3 power 2 here into multiplied by 1 only. Then come to the 25. 25 can be divisible by 5 only. 5 5 is 25. Then 5 ones are 5. So HCF is 8, 9, 25 is all are having 1 1 1. So HCF is 1 and LCM is 2 power 3, 3 power 2 and 5 power 2. These are all the numbers we have to write. Then 2 power 3 is 2 2s are 4, 4 2s are 8. Then 3 square is 3 3s are 9 and 5 square means 5 5 is 25. So we will get 1800. So by the prime factorization method applying here we can find the HCF and LCM. Thank you. Hi dear students, we can go the find the LCM and HCF of the following integer by applying the prime factorization method. The number is 12, 15 and 21. 12 can be split up into like this. 2 6 are 12 and 2 3s are 6 and 3 1s are 3. Then 15 can be split up into 3 power 3 5s are 15. Then 5 1s are 5. Again 21 can be split up into 3 7s are 21. 7 1s are 7. So HCF of 12, 15, 21 is 3. Because 3 is here, 3 is here, 3 is here, so which is common in all the numbers, which is repeated in all the numbers that we have to take here. So it is 3. And come to the LCM of 12, 15 and 21. It is 3 into 2 power 2, which is having highest power, and 5 power 1 and 7 power 1. When we have to multiply, we will get 420. This is the way of solving the problem. Thank you. This is the important question. Given that HCF of 306 into 657 is 9 and we have to find the LCM of 306 into 657. Already we know that, already they have given that HCF is 9. HCF of 306, 657 is 9, and now the HCF, the formula is that HCF of A, B into LCM of A, B, that is equals to A into B. So as this rule we can write it like this: HCF of 306 into 657 into LCM of 306 into 657, that's equals to 306 into 657. So already we know that HCF is 9 into LCM we don't know, we have to take like this. Then 306 into 657, then shift this 9 to this side, so you will get divisible by 9. So 9 ones are 9, 1 not 2s are, then 3 3s are 9, then 3 1 not 2s are, then 3 34s are. So 34 into 657. So 34 into 657, so you will get 22,330 8. This is the LCM of 306 into 657. Thank you. Hi dear students, today we are going to prove another problem. Prove that root 5 is irrational. Root 5 is irrational. The first step we are taken as we have to assume that root 5 is rational. This is the first beginning step we have to write that. We have to assume that root 5 is rational number, and we have to take that there exist co-prime integers a and b is not equals to 0, b is not equals to 0. It means that root 5 will have the co-prime integers like a and b or p and q, whatever alphabets you can take. It should be particularly ab is the easiest one. We have taken that a and b. Instead of a and b we can take p and q also. Then next step is, so root 5 is equals to a by b. Root 5 is equals to a by b. So here so much things is given, it is not at all necessary here. So I will go and take a new topic, new page of this one. Here root 5 is equals to a by b. Here we have to take that root 5 is equals to a by b. Then shift this cross multiplied, shift this b to multiplied with root 5. So you will get root 5 into b equals to a. Then squaring on both the sides, you will get square it, root 5 b whole square, and multiply this one with square. So you will get root will get cancels each other, students. 5b square equals to a square. So shift the 5 to this side, so you will get, I'm writing here 5b square equals to a square. Shift this 5 to this side, so you will get b square is equals to a square divided by 5. This is important. So we will get 5 divides a square. Then 5 divides a square, you will get like this, students. 5 divides a square divides 5. So it is written here 5 divides a square, such that 5 divides a also. As the theorem we can tell that 5 divides a. So a can be divisible by 5. Let we can assume and we can take that a is equals to 5c. Instead of b we are taken here c instead of b. I am writing here 5b square is equals to a square. Instead of b I am writing here 5c square is equals to a square, ac square, a square. So square nothing, no need. So we can take 5c is equals to a. That we have written here. Here C is some integer. We have to tell that why we have taken C. C is also some integer. Substituting the value of equation 1, A in equation 1, what is the value of A now? It is 5C. We are having A is equals to 5C. This one applying in the equation 1. So we get 5b square is equals to 5c square. 5b square is equals to 5c square. Here 5b square instead of 5c square, square will be applied here. 5 whole square into c square. So 5 square means 25. So we have written here 25 c square. So 5b square is equals to 25 c square. B square is equals to 5c square. B square is equals to 5c square. Here 5 will divide the 25. So 25 divided by 5. So 5 ones are 5 fives are. So 5 will remain. That 5 is written here. B square is equals to 5c square. So shift the 5 to left hand side. Here the next step I am writing here, students. 5c square is equals to b square we are having. Shift this 5 to this side. So you will get b square divided by 5. We can tell this one as 5 divides b. B square as b also. So we can tell now 5 divides b square. So 5 divides b also. This taken as equation 4, or we can mention it is equation any one of the naming. From equation 3 and 4, here we have written equation 3 and 4, 3 and 5. We get A and B. A and B both have common. Here both A and B have factor 5 because 5 is here. So we have taken that factor 5. This contradicts the fact that A and B are co-prime. Our assumption that root 5 is rational number is wrong. We have taken already beginning that root 5 is rational. It is wrong now. This contradicts that root 5 having 5 common factors. Like this we can tell. So what we have taken, root 5 is rational. In the root 5 is rational, A and B is a co-prime. So we will get a 1 as a common. But here we will get the common factor as 5. So we can tell that root 5 is a rational. Root 5 is a rational is wrong assumption. So root 5 is irrational. Root 5 is irrational number. So root 5 having 5 common factors. As this all the things we will conclude that, and we will tell that root 5 is irrational number. For this one we will give the perfect proof of that one, or easiest way. Prove that root 5 is irrational, and we have to prove that root 5 is irrational. We have to assume the opposite. We have to assume that the opposite statement, that is root 5 is irrational. So that is root 5 is rational, we have to take as a assumption. Assume means assumption we are taken to ourselves. Hence root 5 can be written as in the form of a by b. Root 5 can be written in the form of a by b, where a and b is not equals to 0 or co-prime, no common factor other than 1. Co-prime means the other fact other than 1 there is no co-factors. Hence root 5 is equals to a by b. 5b is equals to a. Here root 5 is cross multiplied here. We can take that as root 5b is equals to a. Squaring on both the sides we will get 5b whole square. 5b whole square is equals to a square. Here square will cancel, so 5b is equals to a square we will get as like this. Then 5b square is equals to a square. Then shift this 5 to right hand side, you will get a square divided by 5. A square divided by 5, you will get a square divided by 5 is equals to b square. Hence 5 divides a square. You can tell that hence 5 divides a square. By the theorem, p is a prime number and p divides a square, then p divides a, where a is a positive number. By this theorem we can tell that 5 divides a also. 5 divides a also. So next we are moving next to, hence we can say that a by 5 is equals to c. Instead of a by 5 is equals to b, here we can take an as a by 5 is equals to c, where c is the common integer. So a is equals to 5c. So by these things, now we know that already 5b square is equals to a square. Putting a is equals to 3c, what we now we have taken for this c, that is equals to 5b square is equals to 5c square. 5b square is equals to 5 5 is a 25. Here 5c square can be splitted into 5 square is equals to c square. I mean not equals to, it is a multiplication, c whole square. So 5 5 is a 25 into c square. So 5b square is equals to 25c square. Shift this 5 to this side. Here we are having 5b square. Shift this 5 to this side, you will get 25 by 5 c square. 5 ones are 5 5s. So we are having 5c square. So that is written here. B square is equals to 5c square. So b square by 5 is equals to c square. Hence 5 divides b. According to the theorem of p is a prime number and p divides a square, then p divides a. P divides a here. A is also positive number. We can tell that by these things. 5 divides b square means 5 divides e. 5 divides b. 5 divides b also. By these things, 5 divides b also. By 1 and 2 equation, 5 divides both a and b. Hence 5 is the factor of a and b. Hence a and b has a 5 factor. These 3 points are very very important. Put star mark, and once you take down these things in your notes, therefore a and b are not co-prime. Hence our assumption is wrong that root 5 is rational. So by contradiction we can tell that root 5 is irrational. Hence it is proved. Hence we have proved. So we can conclude that we have assumed that root 5 is rational, but at the end we have proven that root 5 is irrational. And another thing, we know that root 5 having factors of 5 factors it can have. So it is generally our assumption, we can tell that root 5 is irrational. This is the end of the problem. We have to tell that by contradiction root 5 is irrational, therefore root 5 is irrational. We have to write like this. Here I can't write, so just adjustment I am doing here, just to analyze that. After this, by contradiction root 5 is irrational, you write root 5 is irrational. So this is the proof of root 5 is irrational. Now we can go for next problem, that is, hi dear students, this is the another question in the exercise part of the real number. Prove that 3 plus 2 root 5 is irrational. 3 plus 2 root 5 is irrational. Already we know that root 5 is irrational. Then it is very easy to prove that 3 plus 2 root 5 is irrational. See, the assumption, first step is we have to assume that root 3 plus 2 root 5 is rational. Here in the question they have given irrational, then also we have to prove that it is a rational. It is not possible to prove that it is rational, so we have to take the like it is a rational. Let us assume that 3 plus 2 root 5 is rational. Why I am taking this PPT means it is very easy to write down it for your notes. So I am telling again and again, take easy steps. You are comfortable, you can memorize, you can very easily take into your mind, means you take such points. So 3 plus 2 root 5 is rational. This is the first step we have to take. Second step, there exist co-prime integers a and b is not equals to 0, such that this is the second step we have to write again. Then we have to write 3 plus 2 root 5 is equals to a by b. So a by b as integers we have taken, so we have to tell that 3 plus 2 root 5 is equals to a by b. It is a rational number. A by b is represented as rational number. B is not equals to 0, and a and b are co-prime integer. Then you can shift the 3 to right hand side here. We should shift the 3 to right hand side. We will notice that remaining part is 2 root 5. 2 root 5 is equals to a by b. When the from left hand side to right hand side you are shifting any number, it will changes its sign. So here already it is in the form of plus, here you will get a minus. Here you will get minus. Root 2 root 5 is equals to a by b minus 3. So 2 root 5 is equals to, take the LCM, here nothing is there means 1. So b is the LCM, here multiply by b, here also multiply by b. So you will get a minus 3 into b, 3b all divided by b. So in the numerator a minus 3b will be there, in the denominator b will be there. Then shift this 2 to left hand side to right hand side, it will comes to the multiplied with b. Root 5 is equals to a minus 3b divided by 2b. Since a and b are the integers, we know that a and b are the integers. So next is we have to take that a minus 3b is rational. A minus 3b, what it is there here, this we have taken here. A minus 3b is rational, because already root 5 we know that root 5 is rational. Root 5 is rational. Already we have proved, no students, that one I am thinking here, and we have to think like that. Root 5 is rational, and here root 5 is rational means a minus 3b divided by 2b also should be rational. So therefore we have taken, that is important, therefore Because of this one only we are proving like that. We have to mention that one. A minus 3b divided by 2b is irrational. We know that root 5 is also rational. This contradicts the fact, because root 5 is rational. Here root 5 is rational means how it will be, this one is will be this one is also will be rational, and we can't judge that it is rational now. So this contradicts that fact. Root 5 is irrational, because vice versa, because before that one we have taken root 5 is rational and we have proved that root 5 is irrational. Here also root 5 is irrational, and here also we have taken that root 5 is irrational. Then we can tell that a minus 3b divided by 2b is also irrational. A minus 3b divided by 2b equals to root 5. Already we proved that root 5 is irrational. So a minus 3b divided by 2b also irrational. So our assumption that 3 plus 2 root 5 is rational number is wrong. Here 3 plus 2 root 5 is not a rational number. Here we can tell that 3 plus 2 root 5 is irrational. This is the easiest way you can write in your examination. Very easy to memorize also. You can keep it in your mind also. Very easy topic, students. Take all the step by step with every point. Don't forget these points. In all the questions, these points only will repeat. These points will only you should write. Other than your writing means you will lose marks, and they will not give the marks for extra what you will write. Step by step marks will be there, so consider only these points. It is very easy. Then in the next section we will go for next problem. I hope you understand these two problems. You write and study once. Don't forget all the step. When you write more, you will understand more. You will come some little doubts. When you write step by step once again and again, you will repeat means you will understand everything. Thank you. Hi dear students. Today we are going to take new question. Prove that the following are irrational. So we have to prove that 7 root 5 is irrational. So in 7 root 5 is irrational means we have to assume, the first step is important, assuming. Let us assume that 7 root 5 is rational. The reciprocal or opposite to the question, we have to take 7 root 5 is irrational. As in the question, we have to take 7 root 5 is rational. Then second step is there exist co-prime integers a and b is not equals to 0 such that here a and b are the co-prime integers and integers also, but b should not be equals to 0 such that 7 root 5 is equals to a by b. We can tell that 7 root 5 is equals to a by b. Then 7 is not having any root, so shift the 7 to this side, so it will come to the denominator. We can write it as root 5 is equals to a by 7b. Here already we know that in previous problems we have proved that root 5 is rational. Root 5 is rational, but it is irrational. Root 5 is irrational. And if here we have considered that 7 root 5 is rational, so we have to tell that a by 7b is also rational, but root 5 is irrational, then a by 7b is also irrational. So here this point we have written, they have taken here root 5 is equals to a by 7b. Next, we can move further for the next step. Since a and b are the integers, it implies that 7b is also integer. So a by 7b is rational. According to this one, 7 root 5 is rational. Then a by 7b is also rational. It implies that this contradicts that fact that root 5 is irrational. Already we have know that root 5 is irrational. So our assumption that 7 root 5 is rational is wrong. So therefore we can tell that 7 root 5 is irrational. Only this much proof you can write in the examination. If they ask like these questions, it is very easy to write also. All the steps you have to be consider. Then other than these things, nothing you should write. See, this is not necessary, these words. This is not in this one also. Just analyze these questions. It is very, very important questions. Some other questions, extra questions, you can solve like this with 4 to 5 steps. Next, we can go for next problem. Prove that the following are irrationals. Following are irrational. Students, take these all the problem and solution in your notes with step by step. Then only you will understand properly. With seeing all these things, you can't memorize also. You can't be stored in your mind also. Prove the following are irrational. Here, prove the following are irrational means we have to show that 6 plus root 2 is irrational. Here, already we proved that 7 root 2 or 2 root 5, some other problems, but here with plus 6 plus root 2, this is how some difference is there, but it is easy to understand. Now you see here 6 plus root 2, we have to take 6 plus root 2. We have to prove that it is equals to or it is irrational. Now let us assume that 6 plus root 2 is rational. Opposite to the question, we have to take the statement. In the question it is given that 6 plus root 2 is irrational, then converse of that one, 6 plus root 2 is rational. We have to take, there exist co-prime integers, that is a and b is not equal to 0, such that we can write it as 6 plus root 2 is equals to a by b. Here 6 is having plus, nothing is there means it is having plus sign here. Here you can shift the 6 to right hand side. In the 6 plus root 2, you can shift the 6 to right hand side. 6 is containing nothing sign means it is having plus sign. So when you shift the plus 6 to right hand side, it will become minus 6. So root 2 is equals to a by b minus 6. Already we know that root 2 is irrational. We have proved. Already we have proved that it is irrational. So it will become here minus 6. Root 2 is equals to a by b minus 6. Root 2, nothing is there means take LCM. B is the LCM. Multiply by b here in the numerator and denominator. So you will get b is in the denominator 6 minus a minus 6b. Multiplication of 6 into b is 6b. So root 2 is equals to 6 minus a minus 6b divided by b. Then we should make the sentence, since a and b are the integers, it implies that a minus 6b is also integer. A minus 6b is also integer. A minus 6b divided by b is rational, which implies that it is also irrational. Already we know that it is root 2 is irrational, but we have taken that rational. Like that only we have taken here, it is rational, so which implies that it is also rational. A minus 6p is also rational. This contradicts the fact that root 2 is irrational. Our assumption that 6 plus root 2 is rational is wrong. We have known that, assumed that 6 plus root 2 is rational. What we thought it is wrong. So 6 plus root 2 is irrational. Hence it is proved. These steps are very very important. Step by step method is there. Check once all the steps. All the first step, second step, third, first, second, third, fourth, fifth, sixth. Last is the 6 plus root 2 is irrational. Only these steps are enough to get the marks in the examination. This is important question also. When they are having 6 plus root 2, you can take 6 minus root 2. Whatever you want, you can take by changing the sign, or you can take a minus 6 plus root 2, or 3 plus root 5, 2 plus root 2, whatever. But method is same. On all the procedure of writing is same. All the steps are same. You can take all the steps like this one by one. You will get the full marks. Each step contain half marks. So you will get this question for 3 marks or 2 marks. Next we can move for next problem. Very very important problem. This is both the numbers having root. We can take it as step by step. I will explain. Just be careful when you are listening. Prove that root 2 and root 5 is irrational. We have to prove that root 2 plus root 5 is irrational, but we know that just for our memory purpose, we are telling that root 5 is irrational and root 2 is also irrational. Both if we add means we will get the irrational number only. If one example, generally I am telling root 2 is irrational plus root 5 irrational. If we add these two numbers, we will get the irrational only. This is the logic we have to think in our mind. Then first step is, let us assume that root 2 and root 5 is rational number. That is the first step we have to take. Root 2 and root 5 is rational number, so that their co-prime numbers or integers are a and b, such that root 2 plus root 5 is equals to a by b. Here nothing is there to shift. If plus 2 is there means we can shift, here minus 2 or any number is there means we can shift, but here no number, both are having roots, so we can't shift. But one of the method is squaring the both the sides. Squaring both the sides, we will get that root 2 plus root 5 whole square a by b whole square. Next we can tell that root 5 plus root 2 whole square, so it is in the form of a plus b whole square is equals to a square plus b square plus 2ab. Like that we can consider that root 2 plus root 5 whole square, that is equals to root 2 whole square plus root 5 whole square plus 2 into root 2 into root 5. So root 2 whole square means square will get cancelled, 2 plus here also root 2 will get cancelled, 5 is remaining, plus here 2 into root 2 into root 5 we can multiply that, root 10, 5 to is 10. So we will get this answer, that is they have written here already. that is 2 plus 2 root 2 plus 5 plus 2 root 10 equals to a plus b whole square. Is that no? That one they have split it in written. This also I will write here. A square a by b whole square, that is equals to a square divided by b square. This one also they have written here, a square b square. The splits and they have written according to the laws. Now we are having numbers here. We are having numbers here. 2 plus 5, that is equals to 7, and here plus sign is there. You can see that plus sign is there. So 7 plus 2 root 10 is equals to a square divided by b square. So shift the 7 to right hand side. So you will get, I will write here, 7 plus 2 root 10 is equals to a square by b square. Shift this 7 to this side. You will get a square by b square. Here it is 7, it will become minus 7 here, minus 7. So nothing is there, means we can consider that 1. Then here b square, but here 1 is there, multiply by b square, and here also multiply by b square, taking LCM both the sides. So you will get b square as the denominator. In the numerator you will get a square minus 7b square. So that one we have written here. This is the step we are having here. So 2 root 10 equals to a square minus 7b square divided by b square. Then we going for next step. 2 root 10, if continuity of this step I am writing here, 2 root 10 is equals to a square minus 7b whole square divided by b square. Shift the root 2 to right hand side. You will get root 10 equals to a square minus 7b square divided by, here 2 will come to the denominator, 2b square. This is the root 10 is equals to a square minus 7b square divided by 2b square. If anything that is having root with number, means root 10, root 5, root 2, all these are irrational. So here a square minus 7b square, 2b square divided by 2b square also irrational. Hence we have proved that root 2 plus root 5 is an irrational number. Here the next step, already we have taken that 10 is equals to root 10 is equals to a square minus 7b square divided by 2b square. Here a square minus 7b square divided by 2b square is an rational number. According to the question, we have taken that root 5 plus root 2 is rational. We have assumed that one. Like that only we have taken this one, a square minus 7b square divided by 2b square is an rational number. This implies that root 10 is also a rational number. Root 10 is also a rational number. So, but already we know that root 10 is irrational number. Therefore, there is a contradiction and our assumption is wrong. Our assumption of that, what is our assumption? Root 2 plus root 5 is rational. This assumption is wrong. So root 2 plus root 5 is irrational. So we can finally tell that root 2 plus root 5 is not a rational number. It is not a rational number, but hence we have proved that root 2 plus root 5 is irrational number, hence proved, or hence it is proved. At the end of this one, this is the word we have to write, these words, hence proved. Then only it is concluded or ended here. So it is also very important problem. You should not forget to do this problem. Different numbers they will ask. Root 2 plus root 5 is there. Other than root 2 plus root 5, they can ask some other questions. Root 2 plus root 3, or root 2 minus root 5. Any these numbers, root 3 plus root 5, any of these problems you have to solve by these methods. I hope you understand everything, step by step explanation, and everything you should keep in your mind. Once you write in your notes with your own handwriting, then you will understand the concept easily you can study. These are all the topics very easily we have explained here. You should understand carefully. Next we can move that very important problem in the CBSE. Prove that cube root 5 is an irrational number. Let us assume that cube root 5 is a rational number. This is the assumption we have to take. So there exist co-prime integers a and b is not equals to 0, such that cube root 5 is equals to a by b. I am writing here. Here already cube root is there. Still now we have studied about square root. So cube root is there means we have to cube. We are telling that squaring on both the sides. We have to tell now cubing on both the sides. This is the next step. We have to cubing on the both the sides. If you cubing on the both the sides, we will get that this is equals to whole cube, and a by b is equals to whole cube, a by b whole cube. So you will get this cube root will cancels each other. Here according to the formula we can write it as root 5 equals to a cube divided by b cube. So here we can write it as 5 is equals to a cube divided by b cube. Nothing is that means 1, cross multiply it, you will get 5b cube is equals to a cube. Here 5b equals to a cube means we have to shift the 5 to right hand side. We will get b cube is equals to a cube divided by 5. So that is written here, b cube is equals to a cube divided by 5. Here 5 divides a cube. Here 5 divides a cube. Then 5 divides a also. We have to tell that according to the theorem, 5 divides a cube. That implies that 5 divides a. Then 5 is the factor of a. So that we will tell that 5 is the factor of a. A is having 5 factors. Let us a is equals to 5c. Now we can tell that a is equals to 5c. Instead of b, we can take that c. A is equals to 5c. So applying this one for this equation, value of a. Here we will get the same thing here. B cube is equals to 5c cube divided by 5. So b cube is equals to 5 into 5 into 5c cube. Because 5 is multiplied 3 times with the c cube, it is also multiplication. So 5 one time, here 5, here 5, it will cancel. I will write here b cube is equals to 5c cube divided by 5. Here b cube is equals to 5 into 5 into 5 into c cube divided by 5. Here this 5 and this 5 will cancel. 5 into 5 25. B cube is equals to, we can take directly what is remaining, 5 into 5 c cube divided by, nothing is there, it is considered as 1. So shift this one of the 5 to the left hand side, so you will get b cube divided by 5. B cube divided by 5, this 5 will come to, this 5 will come to the denominator part of the here. So b cube divided by 5, that we have represented here, b cube divided by 5, that is equals to 5c cube. What is remaining? This is the remaining 5c cube, that is written here, 5c cube. Then we can tell that b cube is divisible by 5. So 5 divides b cube, 5 divides b cube, then 5 divides b, this is b, this is b. So 5 is the factor of b, 5 is the factor of b. We have to take that equation 3, we have to take as equation 3. Then it is b, don't forget to write, it is b, 5 divides b, so that we can write it as 5 is the factor of b from equation 2 and 3. Here equation 2 is here, here equation 3 is here. From equation 2 and 3, 5 is a common factor of a and b. 5 is a common factor of a and b. A and b we have taken as integers, both are having 5 as a common factor, and a and b are not co-prime numbers. By these things we can tell that a and b is not co-prime numbers. Our assumption is wrong, that 5 cube root of 5 is an irrational number. We can hence prove that cube root of 5 is irrational number. It is important problem, don't forget this type of questions. So many questions they have repeated. Very very easy steps I have explained here. Thank you. Before analyzing the question, you have to write once or twice, then only you will understand these problems. Thank you, students.